As a leading manufacturer of compact controllers in Europe, JUMO produces a multitude of control units. For easy control tasks, besides mechanical thermostats, different electronic thermostats and microstats are available. Together with RTD temperature probes, thermocouples, or different sensors with standard signal output, electronic thermostats are used for controlling temperature and further physical variables. For superior control tasks, controllers with PID control algorithm are used. The JUMO product range includes several compact and process controllers. Here it can be seen exemplarily. A controller of the series d-tron 300. This is a compact controller with a program function. On the right-hand side, there is a Dicon Touch. This is a two-channel process and program controller with a recording function and touch screen. This video shows important details for commissioning of a compact controller using the controller series d-tron 300 as an example. The controller is available in different formats. In the video, it will be used a d-tron 304, size 96 mm as an example. The movie informs about wiring, configuration and operation of the device as two-state controller and as continuous controller. The factory setting of the controller configuration is suitable for the following application: measurement of a temperature at input number 1 with a RTD temperature probe PD100 in 3-wire circuit. The controller controls the temperature as two-state controller. Operation of the heater via the contact of output number 1. In many cases, changing of the configuration is not necessary. In the case of another application, the setting of the controller is possible in the configuration level. The compact controller has got 3 levels: operating level, parameter level and configuration level. For many applications, the configuration of the submenus Inputs, Controller and Outputs is sufficient. The following application generally complies with the factory settings. But a transmitter with range 4 to 20 mA provides a temperature signal. This corresponds to a temperature range of 0 to 200 centigrades. The settings must be done in the menu Inputs in the configuration level. The manual for the d-tron serves as an add. For input 1, it has to be defined the signal 4 to 20 mA in the configuration level. It's a linear signal. Setting of scale for the 4 to 20 mA input signal is 0 to 200 centigrades. Subsequent, the configuration is shown via the device front. The settings are made in the menu Inputs of the configuration level. The signal for input 1 is a 4 to 20 mA signal. And shows linear behavior. 20 mA represents a temperature of 200 centigrades. The configuration of the controller is done. After definition of an exemplary set point of 150 centigrades, the controller heats until 150 centigrades has reached. But in most applications, PID action is required. The controller offers the possibility to find out control parameters with the auto-tuning function. After pressing the arrow keys up and down for the same time, auto-tuning is started. The controller switches the heater alternately on and off and produces the oscillation of the process value below the set point. After completing the auto-tuning functionality, the controller has found good control parameters for the most plants. The parameters are stored in the first control parameter set. The controller has determined the values for the proportional band, the derivative time, the reset time, and furthermore, the cycle time. With the founded parameters, the controller controls to the defined set point. The configuration can be done alternatively with a configuration program. For transferring of configuration data, the PC interface USB TTL converter is necessary. The shown PC interface USB TTL converter connects the computer with a Detron 304. Start of the configuration program. Once the kind of connection must be defined. The communication will be occur with a virtual serial interface. The COM port number must be chosen. The device is shown in the device list. Now the connection to the device is possible. Using the configuration program, the controller should be configured for the following application. In an annealing furnace, temperature measurement is done with a RTD temperature probe in 3-wire circuit. The heating of the plant is affected electrically by a power controller. Operating the power controller is done with a 4 to 20 milliamp signal. Proportional to this signal, the power controller gives electrical power into the heater. A new file is created. The controller has a modular construction. 3 slots can be used for different boards. Adjusting the dialog window to the existing hardware is necessary. The easiest possibility is automatic recognition. The analog output exists as an option board. In the example, this board is placed in slot 2. With the used RTD temperature probe, the factory setting in the menu Analog Inputs can be utilized. Continuous controller must be chosen in the menu Controller. For auto-tuning, it must be defined that the used controller output 1 for heating exists as an analog output. Some kind of controllers have got 2 outputs regarding the controller function. For example, heating and cooling of the three-state controller is done via the so-called first and second controller output. The continuous controller of our example has got only the output regarding the controller function. The first controller output is assigned to the first binary output as standard. This output is deactivated when using the continuous controller. For the continuous controller, the first controller output is assigned to the analog output. Here, this is output number 6. The signal is 4 to 20 milliamp for an output level of 0 to 100%. For wiring of the components, the function connection diagram is helpful. The RTD temperature probe is connected to terminal 2 to 4 of the terminal block 2. The power controller is connected to terminal 6 and 7 of terminal block 1. If required, the configuration file can be saved. Process variables can be recorded using the startup function. Under Edit Channel Selection, variables can be selected. In the first recording channel, the process value is recorded. In our example, the range is 0 to 200 centigrades. The range of the set point in channel number 2 is 0 to 200 centigrades as well. The output level corresponds to the first controller output and is recorded in channel number 3. Start of the recording. The maximum recording period is 24 hours. After stop of recording, the data can be printed or stored. Thank you for your attention.